In this video, we're continuing our focus on problem-solving methodologies, in particular DMAIC and Lean Thinking's Kaizen event. And we've already taken a look in earlier videos at what a process is, elements of a process, things to consider when you're kicking off a process improvement project. We've also explored the basics behind the steps associated with the five-step DMAIC problem-solving approach and the Kaizen event with its prep phase, execution phase, and follow-up phase. What I'd like to do now, and the learning objectives for this video, are to take a look at the 4 characteristics associated with poorly performing processes. There are many characteristics associated with poorly performing processes, but if we make sure that our process improvement teams focus on these biggies, we'll be more likely to see some of the future state gains that we're hoping for in the systems that we work on improving. So we'll take a look at those 4 characteristics. They include whitespace, rework loops, visually identifiable lean wastes, and up and downstream process variation. We'll give some quick examples in this video, but then there'll be plenty of applied practice and examples in follow-up videos as well. All right, I've cleaned up my screen a little bit and I've got the 4 characteristics listed out. I call them the big 4 secret ingredients to process improvement success. And they are in this order. Number 1, white space. 2, rework loops. 3, visually identifiable waste, sometimes called lean waste. And then number 4, process variation that we see upstream and downstream in the system. And what I'd like to do is give examples of each next. Okay, so I've cleaned up my screen a little bit, and in this next example, I'd like to take a look at white space. White space is a term that I use to describe the idle time handoff in between steps. So I've got a simple 5-step process that I've laid out here. It begins at step 1 and it ends at step 5, with a customer receiving the output from this process. Each of the activities could either be performed by an individual or a different departmental group within an organization, and I'm going to connect each of the activity steps that are the yellow boxes by flow arrows. Each of the flow arrows represents a handoff that takes place from one group to the next. For example, the first step could be a filling out of the form. The next step could be a review of the form for accuracy. The third step could be a data entry step, or a step in which the form in one system is automatically uploaded to a larger organizational database. The fourth step could be from that data entry in the system, the organization withdraws funds from a bank account to pay the employee. And the last step is the deposit of those funds into the employee's bank account, either in the form of a paper check or a direct deposit that occurs. So we've got fill out the form, review, data entry, withdraw the funds for payment, and then deposit funds into employee account. This looks very familiar to some of you in other videos. We've got an example of this process laid out. It's in the travel reimbursement case example, and this is a real high-level view of travel reimbursement. Travel reimbursement is a process in which the customer is an internal stakeholder. This isn't an external customer, but an employee. And they are requesting for repayment of funds in which they use their personal accounts to pay for company-related travel or other expenditures. Travel reimbursement. Great. Okay, so we've got a process laid out. Let's describe what white space is. White space is the idle time handoff in between each step. So let's take a look at the time that's involved in each one of these steps. It's going to help us to better understand what white space is. The time to fill out the form for travel reimbursement, I'm going to say that took me between a half an hour and an hour. Heck, let's call it 40 minutes. The time for my manager to review the travel reimbursement form that I generated, um, not very long, but I'm going to call it 5 minutes. The data entry that took place, because this was a paper-based form that got passed around by our accounting group, let's say that that took an hour. To withdraw the funds for payment from the company's banking accounts and the creation of that check, let's say that that takes another 30 minutes to an hour. I'm going to call it 30 minutes. And then once I've received the check, to deposit that check and deposit it into my account. Well, boy, if it's an direct deposit ACH deposit, it will be measured in seconds. But let's say it's a paper check and it took me an additional 30 minutes to deposit that check. If I add up all of the time associated with each of the yellow activity boxes, the total activity time is 165 minutes. Yeah, 2.5 hours. But when we measure the total time in the system from the beginning of the first step to the end of the last step, the total time in the system we find is it's the activity time plus the handoff time. When we've got the activity time, it's been recorded or observed, and I've laid it out. Let's now go back and insert what the handoff time was. So it turns out that the handoff time between the first step and the second step, after I get done filling out the form and I pass that off to my manager, I filled it out on a Monday morning. My manager reviewed it Friday afternoon. That's 4.5 days. After my manager reviewed it and then passed it to the accounting group for data entry, he did that on a Friday. Data entry on the following Tuesday actually did the data entry. So that's Saturday, Sunday, Monday, Tuesday. That's another 4 days. After data entry completed it, the time that they actually send the request to the bank, that's usually midweek or end of the week. And oh, we missed the Wednesday batch, the midweek batch, so it didn't arrive until Friday. So they did it on Tuesday, Tuesday plus Wednesday plus Thursday plus Friday. Oh, there's another 4 days. The bank withdraws the funds for payment and sends the check back to the organization. But then HR has to distribute the check, and that typically happens on Fridays. So, they cut the checks on Friday. Saturday, Sunday, nothing happened. Monday, the organization received those checks, and then they waited until Friday for distribution. So that's an additional 7 days. So if we add the total time in the system, we've got 2.5 hours for activity time. But for the handoff time, this idle time handoff time, we've got 4.5, 8.5, 12.5, 19.5 days. Total time in the system from the beginning of the first step to the end of the last step, which we give a special name, this total time from beginning of the first step to end of the last step, we call that lead time. Lead time is 20 days. There's only a tiny fraction of the 20 days that's the actual time spent in each one of the boxes. Almost all of the time is spent in Whitespace, idle time handoffs in between each step. And this is for a process that's working, well, working without mistake. There were no mistakes in this system. This was just an idle time handoff waste. Whitespace is a killer. But there are other characteristics of poorly performing processes. All right, I've cleaned up our drawing space just a little bit and made the numbers a little bit easier to add up for me mentally. But we get the sense, again, the activity steps we sometimes call cycle time steps, or the yellow boxes. They are measured in very smaller increments, typically seconds or minutes. And the idle time handoffs, known as Whitespace, much more painful and frustrating. They're measured in days. And now let's take a look at rework, and it's exactly what you think. It's the identified errors or mistakes that have to be corrected before we can receive our fulfilled service request. So for example, maybe there's a rework loop at the review step where my manager finds a mistake in what I had filled out. And at the data entry step, accounting finds some non-allowable expenses and it gets sent back to me. The total amount of time in the system then would be the initial 40 minutes for me to fill it out, the 4.5 days, the review time by my manager, then he identified a mistake, so it gets sent back to me. I spend more time on the form, I pass it back to him, it clears his review, and it goes to accounting. They do 60 minutes of their analysis, identify a mistake, goes back to me for further review, plus and I think you can see if you add up all of the time in this system, including the idle time handoffs or Whitespace, plus the rework loops that occur, we get an awful lot of frustration. You know, for most large enterprise processes, the combination of rework loops and Whitespace can account for well over 90, oftentimes well over 99% of the total time in the system, which we sometimes call lead time. Let's take a look at two other characteristics that we'll be exploring with other case examples next. The third big characteristic is the visually identifiable waste that you see inside each activity step. Whenever you're dealing with visual work, there's often inefficiencies that take place, and there are 8 types that we'll be exploring in our discussion on lean waste identification. I use the mnemonic Tim Woods to remember them. Transportation waste, inventory waste, motion waste, waiting waste, overproduction waste, overprocessing waste, defect waste, and staff skill underutilization. We've got a whole separate video that dives deeper into these, but these visually identifiable wastes, they occur throughout each one of the steps, adding to even more frustration. The last secret ingredient or characteristic of poorly performing processes is the variation that can frequently be seen upstream and downstream. And here's what I mean by this. When I'm filling out a travel reimbursement form that's requesting $32,000 in reimbursable expenses, that should go through a different level of rigor than when I'm requesting $26 in gas money. The more you have upstream variation, a variety of different types of requests or different levels of complexity of the requests coming into the system, that adds to the inefficiency and frustration. We may need all of the steps for this very complex request, but then we still perform those same level of the same number of steps even for a very simple transaction. That can be frustrating. Downstream variation also plays a role. If I get that check back to me deposited in 8, 12 days, I'm okay. If it's 15 days, I'm a little frustrated, but I'm probably still okay. It's those unusually painful 32, 38, 50, or longer days that are really frustrating. If we have output that is not always consistent, that varies, that can add to the frustration as well. We'll look more at process variation in separate videos too. These 4 big characteristics, whitespace, rework loops, visually identifiable waste known as lean wastes, and process variation are sources of extreme frustration. It's our job as process improvement specialists to identify these big characteristics, measure them, and then build future state solutions that attack, reduce, or eliminate these frustrations from happening.